Okay, on to setting up the DOP network. Let's create a DOP network. I'll call it smoke sim. Let's dive inside. We know the ingredients we need already. So we need the pyro solver. We'll need a smoke object. We'll need a volume source. Not a good idea for me to be doing this on a frame that's not frame 1. Volume source goes here, the smoke object goes there. So here on the volume source, we'll indicate the source that we just created. So smoke source, out smoke source. And we want to initialize the smoke. Remember, even though it starts by default with source smoke, nothing is configured. So you need to switch to something else and then go back to source smoke for it to automatically configure these parameters. They're not easy, they're not hard to configure at all, but it's just faster. Now, the next thing is, as you remember, we will need to set up the smoke object size. You can bring, let's go high, let me turn on the visibility of Iron Man, and I'm gonna just open up viewport so we can see what's happening. And here on the smoke seam, I'm just making sure that this is ghosted so we can still see Iron Man. Okay, and we are actually seeing the source as well. So here on setting up the smoke object size, these are the values that I'm going to be using. So it's going to be 1.5, 1.2, 1.2, and we'll set the center to be minus 0.12, 1.5, and minus 0.17. So I tested these this before, so these are the values that seem to be good for the purpose of the first shot camera, for the camera of the first shot. Now, what else? Regarding the pyro solver, I'm gonna do some adjustments here on these settings. So I figured that things were going kind of slow, so we're gonna want them to be a bit faster. Everything's happening very fast, and the simulation just wasn't going at the same pace as everything else. So I increased this value to 1.5, and the temperature diffusion, as we saw before, lowering this can actually allow us to save a bit more detail. So I'm gonna use a very low value, something like this. The cooling rate also, I'm gonna reduce it a bit. And finally, the buoyancy. The buoyancy lift is gonna be low as well, but it was working. I wanted to kind of stay around here for a bit longer, and yeah, this value was working really good. Don't forget, we don't need combustion. And on the shape, we're also going to do a few things. So on the shape, I'm going to make sure we have a bit of dissipation. We don't need too much, just a tiny bit of dissipation. We'll add a bit of disturbance as well, 0.15. And we'll add a bit of turbulence as usual. Turbulence, I'm going to be adding quite a bit. Again, just because it's a pretty fast scene. Everything's happening very fast, and for things to actually be noticeable with the motion of the thunderbolts and the moving of the arms and all that stuff, this intensity turned out to be a good value. On the disturbance, I'm also gonna make a few adjustments here. So on the disturbance, let's say that the cutoff is going to be 0.01. So it's only going to be applied to really the edges of the sim. And the block size is going to be also very small, 0.12. Finally, in terms of using the control, these control settings, we're actually going to use density for this. And the control influence is going to be 100%. And we'll set the control range to be 0 to 0.05. Next, moving on to turbulence. So for turbulence, we're going to be using a swirl size very small with a very grainy type of flow. And the pulse length is also gonna keep at the default value. Just gonna add a few more turbulence here, and on the density, pushing this back to 1 as well. And I think that's all that we're going to be using. Finally, here on the advanced, let's use OpenCL. See if it can calculate with that. It'll be faster. And let me hide this, hide other objects. One more thing. One option here that we have on the shape, regarding the dissipation, we don't actually have an option to kind of diffuse the simulation. The same way we saw that there's this diffuse temperature diffusion there's a diffusion for the temperature. We can also have that type of diffusion on the actual density. And in this case, it seemed like something that would be interesting to have. So you can create a gas dissipate, a microsolver, and we'll connect this here on the advection. So we'll just add a bit of diffusion, 0.01. And finally, don't forget the resize fluid dynamic. We'll also connect this here on the pre-solve. And this is going to be using as a tracking object. Let's say it needs to be at least the size of the source. And this should help us get things even faster. Regarding the smoke object, the division size, this is just too big. Let's start with something like 0.205. I'm going to copy this parameter, go to the source, and actually paste that parameter here. Not here, on the rasterize, sorry. Base relative references. Hide this smoke source. And let's see how this looks like. I'm just going to do save. Okay, so we need to add a bit more density to this. Let's make sure that here on the volume source, when we're bringing up the density, let's say we're scaling these values to 3, and we actually want them animated. We don't want it to start immediately at 3. So let's say that I'm gonna turn off the auto update here, turn it to manual, and I'll set a keyframe here by holding Alt and pressing on the parameter. I want it to start at 0. And then at frame 6, I'll set another keyframe, holding Alt and clicking, and I'll say it's going to go up to 3. And that way we have a bit of a coming in. Let's go to auto update. Go ahead. Simulate. So they will stay a bit longer. So this takes a bit longer to calculate. So I'm gonna just focus on the shot itself. So I'm gonna lower here the duration of this. I'm gonna put it to 40. Apply. Close. Let's see how we can add a collision to this. Let's have the smoke actually collide with Iron Man.